tradition we made fermented beer.
Did you get to sample it?
If you were over 21, she let you sample it. If you weren't over 21, she was going around policing you. But yeah, it was kind of cool. You opened it up and smelled just like, it's weird.
All right, we're going to work on experiment 7. So, and now that we've gotten through the grams and moles, this will make a lot more sense to you. So thank you for being patient with me. So the goal of experiment 7 was and is to determine the formula of a compound made of magnesium and oxygen. So you're trying to figure out what these subscripts are, so you don't know what they are. So the pre-lab has you go through and determine the formula for a lead compound. So it tells you lead can form 2 compounds with oxygen. Determine the formulas from the following data. A lead oxide compound was found to have a mass of 0.239 grams. It was heated and the oxygen was removed. The remaining lead has a mass of 0.208 grams. So for compound A, the mass that you're going to list for lead is 0.208 grams. To determine the mass of the oxygen, you're going to subtract 0.239 from 0.208. Watch your sig figs. How many sig figs should you record for that? So 3 after the decimal. Well, it's 3 after the decimal. So that's 2 sig figs, but 3 spots after the decimal, yes. Now, you're going to, the next step, and remember the goal is we're trying to figure out what the formula of this lead oxide compound is in this pre-lab. So you're going to convert the number of grams to moles. So I need to convert 0.208 grams of lead to moles. So I'm going to use the molar mass. And if you look on the periodic table, lead has a molar mass of 207.2 grams. You're going to divide by that to get your grams to cancel out. You get a small number. How many sig figs? 3. 0.00100 moles. And then you're going to do the same for the oxygen. Now you say, oxygen is a Hofbrinkel. You taught us it was a Hofbrinkel. You're just going to use 1 oxygen atom. So it's, the molar mass you're going to use is 16.00 grams. So you get 0.00194 moles. Oh, no, you're right. Thank you. It would just be 2.
Right?
Yes. Thank you. Okay, now this part, determine the mole-mole ratio. This is just because you cannot have a formula of PB. Right now you have 0.00100 and oxygen 0.0019. You've never seen any crazy formulas like that, right? No. So we have to have whole number ratios for our coefficients. So what you're going to do is divide by the smallest number of moles. So if it helps you, star the one that's the smaller number of moles. And it's the number, in this case, it's the lead. So you're going to divide both by the number . So you'll end up with a formula. PB will just be 1. And then you're going to round to the nearest whole number. So you get 1.9, it's going to be 2. PB, 2. Okay? I'm going to ask you something and make you use your brains. What's the name of this compound? Lead 4 oxide. You do the cross and raise, and you'll find, well, oxygen's not -1. It's been simplified. So it's lead 4 oxide. Keeping you on
it's
air too.
because there's 2 oxygen.
Mm-hmm.
So you're done -2 charge.
Yes.
Oh, gruesome.
Now, on the back of this pre-lab, there is another lead oxide compound, so compound B. This is going to have a different name. So that's my hint to you. So I want you to work through this one after we're done, but you're going to go through the same steps. The mass of the lead is 0.414. To get the mass of the oxygen, you're going to subtract those two numbers like you did before. So 0.446 minus 0.414. So you'll go through and calculate that and do the ratio like we did. On your data page, on page 57, since we were having some equipment troubles, I'll tell you what you would have done. You would have weighed out a crucible on a crucible cover, then you would have added magnesium to it, then you would have heated the crucible with a Bunsen burner, it would have ignited, you would have heated it, added water, then you would weigh it at the end. So the whole goal of this lab was to determine what the formula of magnesium oxide would be. So I'm going to give you some data. 22.409 grams. So this is on page 57. 22.458 grams. 22.488 grams.
So the experiment that we're not doing was just basically like determining it after a chemical change.
Right, so you're weighing the reagents before and after. And so in order to get the mass of magnesium, you subtract number 2 minus number 1. Get the mass of magnesium oxide, number 3 minus number 1. Mass of oxygen, number 5 minus number 4. With these last 3 entries, watch your sig figs. Sig fig. And then you're going to convert the number of, just like we did in the pre-lab, convert your grams to moles for magnesium and oxygen. For number 9, all you're going to do is get the mass, number 4 mass, the number 5 mass, multiply it by 100, watch your sig figs. And then you're going to go through the same ratio exercise that we did like for the pre-lab. And then you'll get the formula for the magnesium oxide that you made. And then on number 11, determine the simplest formula of a compound with the following data. 1 mole was found of manganese was found to react with 2 moles of oxygen. So the molecular formula would be MnO2. You'll do the same thing here, but remember it has to be the simplest formula. So be careful on the next 2. And then last one, you're going to have to convert grams to moles.